So, hi everybody and welcome back to SAS C++ tutorial series for absolute beginners. This is video 266, and in this video we want to talk about abstract classes. To do so, you go here on the homepage of cppreference.com to language, and then in language, when you click on it, then you go here to classes, and then here down it says abstract class, and you see also here the shortcut for abstract class, which is called ABC, abstract base class. We click on it. All right. And here a side note, an abstract class has something to do with virtual functions. And let's get reading. So it says here, the first line, defines an abstract type which cannot be instantiated but can be used as a base class. So what means that? So when we create a class which is abstract, then we can't create a variable of it. That's it. But we can still use it to derive from it. All right, let's go here to the syntax, and it says here a pure virtual function is a virtual function. So we know what a virtual function is, but we don't know what a pure virtual function is. A virtual function whose declarator, the declarator is just the first part here. You say, for example, virtual int and then the name. This is our declarator, has the following syntax. So it starts with the declarator, for example, with this one, and then the virtual specifier, which we learned in our last video, which is this override and or final, or a combination of this one. And this one is used when you are derived from already a base class. And then here is the new thing, this equals 0. If you see this equals 0 in a class, then you must automatically think this class is abstract. And that means this class you can't create an object, which means you can't create a variable. All right, that's so far so easy. And let's go on. So here the sequence equals 0, this is this part, is known as pure specifier. Yes, this is our pure. It makes the normal virtual function a pure virtual function. All right, and appears either immediately after the declarator or after the optional virtual specifier. All right, that's also very straightforward. So we will write this after the declarator, or when you have an override and final word here between after this one. For example, here we have again something like override, and then it comes here is equals 0, or without override, here's just the declarator, and then just this pure function. That would be an example for this, both use cases here. And then let's read here a little bit more. It says here pure specifier cannot appear in member function definition. So in a definition of a member function, we can't use that one. Okay. Or friend declaration. Okay, friend declarations are, we know, external functions which are given permission for accessing private members. So we know this one as well so far. So far very easy. And what you should just remember is when you see this little equals 0 sign after a virtual function, then you know this class is abstract. That is the base thing what you should all time see, and it's very easy. But let's go here through the example and see if we understand this a little bit more in detail. So here we create a struct base, again a virtual function. It's a normal virtual function, and they are creating a virtual destructor, which is a good practice, because when you see the word virtual, just create a virtual base destructor as well, because this is indicating that we are going to inherit this class. And indeed, in struct A we are inheriting it, and it's a public inheritance because struct is by default public. Here's an invisible public. And let's read this line here. So here is they write it in one line all. You can see here as comma separated, and careful about comma separated notation, because this virtual int counts also for this one here and for this one here. So line by line notation would be more readable, but if you see comma notation, careful about this one. All right, what we have here, virtual int f, just normal virtual function, but equals 0, and it makes a pure. So this one is a pure virtual function. And interesting is also here, it is a new definition or new declaration of virtual function. because in our base we have not f, so this is new, so we should also create here a destructor as well, virtual destructor, just in case. And then we have here G override, and if you see override, we learned this, we know this already exists in the parent class or one of this higher hierarchies, and indeed it exists here, and we are overriding it here. But interesting it how we override it. You can see we are making it a pure virtual function, which means this one can be not you have to override it, let's say so. You have to define it in one of the other inherited classes from struct A later. All right, and again, when you see h function here, careful, this is not h function, this is a virtual int h, which means it's a new virtual function here as well. All right, so far straightforward and easy. And then we go here to this one here. It says here, first of all, this is our destructor. And now we see again the sign here, which means equals 0, which means we make a destructor pure. And that means you are not providing a body for a body means a definition for it. And in general rule, you should as a starter not mess around with a destructor too much, because we know a destructor's job is just to clean up the object. It is in the process of cleaning up the process, and the compiler should do this as far as the best thing is the compiler make this with other calls in the body of the destructor. But we will see later examples they are using the body to call the body calls functions, and this should only do people who are a little bit more advanced, because that can cause bugs if you don't know what to do, and they do it most time for customized cleanups and something like that. All right, so general rule, just use the default constructor, and as far as possible don't use a body if it's possible. And then here we see we create a new virtual int b function, and we make it pure, so all fine, but here we are providing a definition, a body, and that is not allowed. When you see this sign equals 0, you are not allowed to create a definition, because the job to create this definition is from the derived class. And that's why you are indicating I don't want that this struct A has here a definition. I want that who is inheriting from struct A should define this body in his class, not here. And here I must say there is an exception, and this exception many people oversees, and it is danger. Let's read this one here first, and then I try to explain this exception. So an abstract class is a class that either defines or inherits at least one function of which the final override is pure virtual, which means, like I said before, if you see only this sign in the class at least one time, then you know this class or struct is automatically abstract and you can't create a variable for it. So let's talk about this little exception here. In general, when you see this one here with this pure virtual fire, you are not allowed to do this, and that's right. But you will see that you can define this one here, exactly the same thing here, but outside, and provide a definition for this one outside of the struct or class. And many people would say then that's wrong. It is not wrong. And why is this not wrong? Because many people forget this is a virtual function. Yes, it is a pure virtual, but still it is a virtual function. And virtual function means you have the option to call the virtual function, or, and that is what many forget, you can call also the non-virtual version of this function. So without this virtual here. And what was this non-virtual version again? Let's go here back to virtual function specifier, and that was here very mentioned here in this last sentence very briefly. That was this sentence here. It says here virtual function call is suppressed, which means you are not using the virtual function call if the function is selected using qualified name lookup. Okay, we have not talked about this qualified name lookup, but it explains here what it is. That is, if the function name appears at the right of the scope resolution operator, and this one here, when you call it with this with this scope resolution operator, you are not using here the virtual function call. You are using the non-virtual function call, which is just int b, and then you can provide here a definition. And careful about starters, when you see this one, just don't provide a default definition, because many people will say that's not allowed, but it is allowed. It is, and we have it here as well. You can see here, this is the virtual function call. You are not using the virtual function. That was, where is this example here? Yeah, I can use here. We make here this f. We have here a function f in the base, and then we have a virtual function f in the base, and then we are overriding it here in our derive. But you can see, because we want make this one virtual, that's why we make this normally. And then they are using this as well here with this calls, this virtual function calls. And the argumentation is, in general, when you make a virtual, then use the virtualization method and not the base call. But again, here they say, I'm not interested in the virtualization of this function of the base here. That's why I call it with the syntax, and this is this one here, base. So you're calling the base, colon f, and that means don't use virtualization. So here it is calling this one. Then in this way, it is not going down. It is not checking, even if it says here virtual. It is suppressing here. That's very important. This virtual, it is kicking out, and it treats this one as a normal function, which means it will execute this one. Oops, sorry for that. It will execute this one here. All right. That's very, very important, because now in pure virtual function that works as well. And that is the thing what many forget. Here we have, for example, virtual function call. You are not allowed to make a definition. That's why they call it pure, but they forget it. I can call the non-virtual function, and a non-virtual function can have a body, but careful. This definition is not allowed in the class, and that's the very important rule. It must be outside. All right, and here I won't stop, and in the next video I will continue, but more with examples to show you this one, and with code and compiler a little bit, because that's very important. But again, let's repeat here one more thing. The general idea is, when you are declaring a pure virtual function, it's very easy to identify. It's this equals 0. Then you know the class is abstract. You can't make a variable about it, which means you can't instantiate it. And you should not provide a definition like so. This is an arrow, but you can provide one of outside, which is a default definition and most time used for the non-virtual call in a special case. But if you are discussing this in the web, many people will say that's not allowed. Because they forget this, you can make this outside. But in general, as a starter, don't make it too. Just use virtual pure function, because the indication is, if you make it pure, you want that the derive class should define it, and here should normally be nothing. All right, so that's for the first part. We will talk in the next part a little bit more with the examples. And like all time, if you have any questions or anything else, write in the comment section. See you in the next video. Bye, have fun, and good luck.